So hi everyone. So welcome back to our channel, that is a generative mind AI, and this is going to be the second video of the series of NLP using a transformers. In the last video we have just seen about the three era of the NLP, the rule based era, then we move to the statistics era, then finally we move to the deep learning, which say the neural era. Okay, so I hope so that was the introduction part, from where we have just went through and what we are just doing nowadays. So now we are going to more depth in the word vector. So before jumping to the models and understanding the RNN model, LSTM model, transformer model, self attention, these all thing models, we are going to focus on the word vector and the what is the word vector, and basically we'll understand the representation in the vector space. Mostly we are going to do over of the word to vec, how we are just doing basically word vectors, and how we are just performing the word embedding, how the vector is going to be representation. This all thing we are just going to talk in this video. Okay, let's get started. The first thing is basically word vector, also we can just say that is also known as a word embedding, or numeric representation of the word in the continuous vector space. Basically you have a words, okay, you have different type of words, and each words you need to have something label in that, because whenever you are going to feed something string data or anything to your machine, the machine don't understand anything about the string object type. They only understand the numeric data. Clear? Because it is really easy whenever you are dealing with the images data, because images already it has the pixel values, and from that pixel value you don't have to do something like word to vec and this all thing. Okay, pix to vec or something. So in the word embedding you need to convert your words into a, first of all, into numeric representation, and that numeric representation is basically we are just going to talk in these videos. So in that numeric representation, it just captures the semantic relationship between the words. Suppose you have some words like cat and you have words something dog, you can give a label as cat as one, dog as two, but you don't have anything relation between one and two. Sometimes the machine will understand like two is greater than one means dog is more priority than of the cat, but that does not make any sense. Okay, so for that reason we are going to use a word to vec, means you are just having two words, and that two words will have some vectors, and that vectors will be correlated with each other, and we'll just go with that deeper whenever we are going to talk about word to vec. Clear? In the second point, if we are just going to see in a vector space, each word is represented by a unique vector, because whenever you have a words, each word you will just represent in a unique vector. Every word will have some vectors, and that spatial relationship between this vector reflect the semantic relationship between the corresponding words. So I hope so that make really sense, and we are going to see about the next thing, that is word to vec. You can just have n number of representation of words into a vector. You can go with the one hot encoding, you can go a word to vec model. So we are just going to talk about word to vec model, because this thing we are going to use in the whole series, because nowadays whether it is a chat gpt and this all thing, they have just using a word to vec model, converting a word into a vector form, and how we are just able to see the vector whichever they have the same relationship kind of the words, you will have the similar kind of the vector. Okay, so the primary objective is to capture the semantic relationship between the words based on the co-occurrence of the patterns in the large corpus, you can just say. And the second thing is that word vec utilizes unsupervised learning to learn word embedding. That is really a good point, because whenever you are just training something a model, if you are just learning NLP, I hope so you know about the k-mean clustering. So in the k-mean clustering, it is a unsupervised machine learning algorithm. So whenever you are dividing anything into a cluster, like if you are dividing into two cluster, three cluster, means you are just dividing into a groups, and similar group, whenever you are just placing a new words, whichever the similar properties it has, it just find the cosine similarities, and if that the similarity belongs to group 1, that words it will go with the group 1, either it is group 2 or either it is a group 3. Okay, this again it is going to be using a unsupervised learning. So it because whenever you have the words, new words, and that words should be have similar kind of vector. If that it belongs to group 1, means all the group 1 will have similar kind of vectors, group 2 will have similar kind of vectors, and so on. Clear? That's why we are using unsupervised learning, because we don't know the label. Because whenever you are dealing with the large corpus data, millions of the words, so in at that point it is really difficult to label each and every words to have whatever the label. So that's why we are going to go with the unsupervised learning. And the third point is basically words with a similar meaning ends up having the similar vector, which already I just spoke just now, and we are just going to use a cosine similarity between the these vector can be used to measure the semantic similarities and whatever the relation between this word is going to be, we can measure with the help of cosine similarities. If the two words have the same cosine similarity, then it might be have ends with the same vector. Now we are just going to go with the really deeper, and we are going to understand this thing. Okay, so what we are just seeing, so you are able to see, it's really the famous, you are going to see everywhere nowadays. But before talking this one, I'll just see, this is, you can just think this one as a unsupervised learning. So you are just dividing into n number of cluster, you can just say, let's say green, whatever the color you are going to see. So this words is going to be have similar kind of vector, this orange will have similar kind of vectors, this blue is going to be a similar kind of vector, because it might belongs to the whatever you have, something like, you can just say it has a crime novel, or it is a children novel, or whatever you have fiction, non-fiction novel. It's like the category which have, and the same similar categories is belong to have the similar, it has the similar vector in the space. Okay, now it's really the famous thing whichever I'm going to explain you, and that we call as a, you can just say about the man's, woman, kings and queens. This is really the one of the most famous things, and I'm going to explain you what the vector is represent. So whenever you will see that man and woman, okay, so man, this is going to be the vector. So what you have, you will x in the x coordinate, that is basically in the y coordinate, you will have all the words, whatever the words you have to be, whatever the words you are going to use, like any training data, for the training data, and you have to just convert that words into a word to vec form. Then whatever the sentence you are going to use, you are just going to convert into a words, and then finally every words you are going to convert into a vector form. Clear? That this is the man vector. So man vector, basically you will just see living being, and then after human, gender, royalty, verb, plural, and this all thing are basically the features of that man. Here I'm, for the sample, I'm just going to show you only 6 or 7, but at the end, whenever you are working with the real world, so you will might label as 1000 vector, 2000 vector, even you nowadays for the GPT, even they are using billions of similarities vector. So how you are going to have the all the vector which has ends up with the similarities, you will have the similar kind of the vector. So you will see that man, living being, it's going to be have living being is going to be have, you will see all ends with the similar kind of vector. Okay, and then after royalty, if you just see the man and woman is going to be have -1, 0.1. But again, whenever you are a king and whether you are a queen, so your royalty is going to be higher, means your probability, you will see the vector of this king and queen is going to have the similar kind of things. Clear? And whenever you are going to do like man, and then after you are just going to be, you can just say man minus king plus woman equal to queen, something is going to be, because you are, if you are going to minus the vector of the man with the king, you will just left with the what the royalty you have. Okay, because you are just going to minus all the man versus man, and the royalty whichever you have, you are going to add with the woman. So whenever woman is going to get from royalty or whatever it has, it is going to convert into a queen. So this is really the basics thing, and this is going to be representation in n dimension space. So this is what I'm just going to talk in this video. I hope so you really like this video, and again we will just see this thing is the really the theoretical part. The practical part we'll see in the coming video. So for the next video, I will start explaining all about the RNN LSTM model, transformer models. Once we will just done with the all kind of models, then again we are going to jump with the coding part, where I will just do all the word pre-processing part. Again, we will just use any deep learning framework like PyTorch and TensorFlow to train any model, any text classification, text generation, similarities check, and semantic analysis. This all thing we are going to see. And again, we will just use a different type of model, whether it's a bird, hugging face, or GPT model T5. This all thing we are going to perform in the whole series. So I hope so you like this video. Please subscribe my channel, and see you in the next video. Thank you.